In the lecture today, we will try to complete all the rest editing commands for two-dimensional joinings. Here we will first introduce some object modification commands. Then we will focus on the description of the field and pattern for two-dimensional joinings. Well, let's first learn some useful object modification commands. The first one we'll learn is the extend command. The extend operation is an opposite operation of the trim. This command can help you to extend objects to meet the edges of the other objects. And if you press Shift button, the extend command can be switched back to the trim command. The second one we will learn is a stretch command. This command can help you to modify the dimension of the objects. And basically, the command can stretch the objects crossed by a selection window or polygon. The third one is the lengthening command. Compared to the previous two commands, this command is very simple. The command can change the length of the objects and also include the angle of arcs. In the next slides, I'm going to show you one demonstration about how to use these three commands in AutoCAD. Well, let's see how to use the extend command. In this figure, you can find that both circle and rectangle are trimmed, and one part of them will be removed from the current joining. In that sense, if we want to recover the circle and the rectangle, you have to call the extend command. So for the extend command, first type extend, and then similar to the trim command, you have to select the objects you want to modify. In this example, we will select all the objects, click enter. Then you will see that the options under the extend command are exactly the same to the trim command. The only difference is that trim command will remove the objects that you are selected in the current joining, while the extend command can help you to extend the line or the arcs to recover the gap. So for this example, if we want to recover the rectangle, you just need to put your cursor at the two straight lines. And if you want to recover the circle, just put your cursor at the arcs. And then you can recover both circle and rectangle. So that's the operation of the extend command. The second command, stretch, is applied for you to stretch some objects in your current joining and modify the dimension and shape of the objects. In this example, if we want to change the dimension and the shape of this rectangle, you have to call the stretch command. Then you will be asked to select the objects. Remember, for the stretch command, you can only use the crossing window to select a part of the objects. If we are choosing the whole objects, then the stretch command will become the move command. So here, we will only choose one part of the rectangle. And the next thing you need to do is to specify the base point and the displacement for the stretching operation. You can choose any point on the screen, define the base point, and then using your cursor to identify the displacement. And with the different directions and lengths of the displacement, you can modify the shape and the dimension of the rectangle. So that's the basic operation of the stretch command. The third command, lengthening, is applied for you to modify the length on a straight line or the include angle on the arc. In this example, I'm going to show you how to use the lengthening command to change the length of this line segment. And originally, the length of this line segment is about 10 units. So first, let's call the lengthening command. Then you will see a set of options, delta, percent, total, and dynamic. First, for delta, this one will define the actual line segment you want to add to the current line. For example, if we want to add 5 more units to the line segment, just enter the value 5 here, and then choose the object. Now the line segment becomes 15 units. And then let's see the second option, percent. This option, you can determine how much percent of the previous line segment you want to keep after the lengthening operation. For example, if we type the percent as 50, then the line segments will be shortened for 50%. For the third option, total. With this one, you can actually define the total length you want to set for the line segment. For example, if we set the value as 20, then click the line segments. Now the total length of the line segment will become 20 units. For the last one, dynamic. With this one, you should first select the objects you want to modify. Then you can use your cursor to change the length of the line segment dynamically. So that's the operation of the lengthening command for a straight line. And if we have an arc, the operation will be quite similar. And the only difference, like for arcs, you should define the angles included by the arc and see how to change the angles under the lengthening command based on these options. So that's all about the lengthening command in AutoCAD. Next, we learn two more object modification commands, fillet and chamfer. The fillet command is applied for you to smooth the corner with arcs, and the chamfer command is applied for you to smooth the corner with straight lines. And remember, for both commands, they are not necessarily applied to the rectangles. Actually, it could be used for any corners generated by straight lines. In the next slides, I'm going to show you how to use these two commands to smooth the corners. Here I will show you how to use the fillet command to smooth the corners generated by straight lines. First, let's type the fillet command. As this command is applied to replace the sharp corners with arcs, so we have to first define the radius of the arc, say the value is 2 units. Then you need to specify the two lines for the corner. Now you can see that the sharp corner is replaced by the arc, and the radius of the arc is 2 units. Next, let's go to see some advanced options under this command. The first one, polyline. With this one, you can actually smooth all the corners of the polyline with one operation. And now all the three sharp corners are replaced with the arc, and the radius of the arc are all 2 units. The second option, trim, is applied for you to decide whether you want to keep this sharp corner after the operation. If we want to keep them, choose no trim, and then you will find that all the sharp corners will be saved for the current joining. For the last one, multiple. With this one, you can actually trim multiple corners with one operation. Trim the first one, second one, and the third one. Once you complete everything, click Enter to exit the command. So this is the operation about the fillet command. The operation of chamfer is very similar to the fillet command. The only difference is that the fillet command will use an arc to smooth the corner, while the chamfer will use a straight line to smooth the corner. So let's see more details about the chamfer command. Once you type the chamfer, you have a set of options. The options about the polyline, trim, and multiple are exactly the same to the fillet commands. The only thing we should know is that how can we define the chamfer line to smooth the corner. So basically there are two different methods, distance and angle. For the first method, distance, you have to define two chamfer distance. The first one has the value of 2 units, second one 1 unit. Then you have to specify the two straight line for the corner. And now you will see that a chamfer line is generated to smooth the corner. The distance from the intersection here to the corner is 2 units. From the corner to the intersection is 1 unit. And that's the way for the definition of the chamfer line with the distance. For the second method, angle, you still need to define one chamfer distance. Say the value is 2 units. And then you have to specify the angle, 45 degrees. And now define the corner. With this definition, the length from this intersection to the corner is about 2 units, and the angle between the chamfer line and the first line segment you select is about 45 degrees, and that's the second method. So that's all about the operation of the chamfer in AutoCAD. The last two-dimensional editing command we will learn here is called a hatch. This command can help you to define certain pattern field inside of some boundaries. Generally, the boundary applied for the hatch command are the two-dimensional lines and objects, including line, construction line, polyline, smooth line, arc, rectangle, circle, and ellipse. And remember, when you use this command, all the boundaries must be displayed on the screen. Actually, before you apply the hatch command, you have to define the hatch island. Generally, the hatch islands are defined as the enclosed area or text objects inside of the hatch boundary, and that means the enclosed area will not include any boundaries. Basically, there are three types of the island detection method. The first one, normal island detection. With this one, any two immediate hatch islands cannot be filled with the pattern at the same time. This figure shows the results of the normal island detection when all the boundaries, including the circles and rectangles, are selected. For the second method, auto island detection. Under this method, only the islands immediately associated with the most outside boundary will be filled with the pattern. For the last method, ignore island detection. With this method, all the islands defined by the boundary will be selected to fill the pattern. So to define a pattern and fill to certain boundaries, you have to call the command bhatch or hatch. Once you type the command in the command window, you need to select the option setting. Then it will pop out the hatch edit window. In this window, you can first specify the island detection method here, including normal, auto, and ignore. Once you define the detection method, you can go to this part to find the method to identify the boundaries. And the boundaries can be selected based on the pick point and add select objects. I will show you the details about these two methods in the next slides. Once you specify the boundaries, you can go to define the characters of the hatch, including the type, pattern, and color for the region. The hatch command provides two different methods for you to define the boundaries. The first one is called a pick points. With this method, you just need to put your cursor at some location of the drawing. Then the hatch island associated with the point will be chosen, and all the boundaries of that hatch island will be selected for the boundary cells. The second method is called select objects. With this method, you can just select the object directly. For example, in this drawing, we can just select the circle as the boundary. Then all the regions inside will be filled with the pattern, and at the same time the rectangle and the little circle will not be selected as the boundary. Also, the command can provide some functions for you to remove the boundaries and recreate some boundaries to your current drawing. Now I will show you how to use the hatch command and all the previous two-dimensional editing commands to finish the figure in this example. In this example, we only know the diameter of the circle, which is about 105 units. Inside of the circle, there is one pentagon, And inside of the pentagon, there are 5 smaller circles which are all tangent to the edges of the pentagon. So we will start with the joining of the circles and the pentagon. First, let's join a circle with a diameter of 105 units. Choose the diameter as 105. And then let's start with the joining of the pentagon. So we call the polygon comments and enter the number of the size as 5. And now specify the center of the polygon, which is the center of the circle. And then choose the inscribed method. Move your cursor to one quadrant point of the circle. Click, and now you define the polygon. Then we have to draw some assistant lines for you to complete the smaller circles. We will call the line commands. First, choose the top point of the polygon here and reach to the midpoint of the bottom. Repeat this process for all the other 4 corners. And then let's start with the joining of the smaller circle. Here, to draw this circle, we have to use the tangent method. And you should know that this circle will be tangent to the edge here. At the same time, we will tangent to this straight line and this straight line. So we will click these 3 lines. Now you get the first circle. And then repeat the process for all the rest 4 circles. And then we can remove the assistant lines. And that's the way for you to complete the boundaries of the object. To fill the pattern in this example, we have to call the command hatch and then go to the setting option. Now, the first thing you need to do is to specify the method. In this example, we will use the normal or the auto method. It depends on you. And let's go to see the normal method. And then we have to specify the characters of the pattern. Here you see that the patterns are all the parallel lines with the angle of 45 degrees. So here you have to select the type as the user defined and then define the angle as 45 degrees. The spacing between those parallel lines are 5 units. So define the spacing here. And the last thing you have to do is specify the boundaries. For this example, we can see that all the circles are applied as the boundaries and the pentagon is not used as the boundary. So we can use the option add objects and choose the circles as the boundaries. In this selection, you will see that the region inside of these 5 small circles are also filled with the pattern. So you still need to define this small part as the boundary. So you have to call the option pick points and then put your cursor here. With one click, you add one more boundary here. And then based on the normal island detection method, this part will be removed and the pattern will not be applied to this region. So that's the way for you to complete the first example. Here we will complete all the 2-dimensional editing commands. After class, you have to spend some time to work on the commands learned in this lecture and get familiar to all the other two-dimensional editing commands in Chapter 3.